Okay, welcome back to another math lesson. Here we are with grade 4 Go Math, lesson 7.6, renaming fractions and mixed numbers. If you want to follow along, you can go to page 301. On page 301, you'll find this lesson. So let's go ahead and erase this and jump right into it. Now, while I'm teaching this and kind of going over it, you're going to hear me use two different terms. So I want to go over what those two terms are before I actually go on and how to do this. The first is going to be mixed number. So a mixed number is a number that has a whole number, such as 1, and a fraction, such as 1/2. So you would say this is 1 and 1/2. So a mixed number has a whole number and a fraction. Another term you might hear me use is improper fraction. Improper fraction. Now, the only thing improper about this is that it hasn't been simplified yet. So if you see a fraction written as 3 over, not 3 over 3, that's not an improper fraction. 3 over 2. 3/2. If the numerator is larger than the denominator, it's considered an improper fraction because we can simplify it into a mixed number like 1 and 1/2. Now, how I did that? Well, we're going to go over it here in just a minute. So don't be confused. Just know that these are the same and that the improper fraction is a number that has, or a fraction that has a larger numerator than it does a denominator. Okay, so on page 301, we have a problem. It says, unlock the problem. Mr. Fox has 2 3/6 loaves of cornbread. So I remember that number. I'm going to write 2 3/6 loaves of cornbread. That is what we're working with. Okay? Each loaf was cut into 1/6 size pieces. So let's go ahead and just draw that. We have 2. Let's cut those into 1/6 size pieces. And then we have an additional 3/6. So we're going to add a third right here and cut that into 6 size pieces. However, because we have 2 3/6, let's make sure we shade this properly. I'm just going to do a quick job. So we have 2 of these ones that are completely shaded in, and then 3/6 or 1/2 of that other one that's shaded in. So the question is, if he has 14 people over for dinner, is there enough bread for each person to have 1 piece? And then it goes into detail, kind of explaining a mixed number a little bit. So let me read that to you. It says a mixed number is a number represented by a whole number and a fraction. You can write a mixed number as a fraction. So mixed number is the number that we have right here. Okay, so we already have our picture drawn. Now we just need to figure out how many pieces, how many 1/6 size pieces we have, and if it's enough for Mr. Fox's dinner party. So let's take a look. First off, we know all of these are split into 6 size pieces. So we know 6. Whoops! Let's bring this down. We know 6 is going to be our denominator. However, we need to figure out how many total we have. So let's see. We have 6 pieces there. We have 6 pieces there. And we have 3 pieces shaded in right there. And that has got to be the ugliest 3 I have ever put on the whiteboard. Okay. So now that we know we have 6/6, 6/6, and 3/6, we're just going to add this together and see if we have enough for 14 people. So we add it all together. 6 plus 6 is 12, plus 3 is 15. And remember, we never add the denominator, so we have 15/6. Going back to the question, it says if he has 14 people over, is there enough for each person? Well, we have 15 6th size pieces and we only need 14. 15 is a bigger number than 14, so the answer to our question is yes, we do have enough. And just a quick little notice, I'm doing something a little different with my camera today. I have a document camera rather than a just my regular webcam. So if you notice I'm kind of moving around or trying to figure out how to make it work, I do apologize, but hopefully I can fit it all on the board. Okay, so just like that, we converted a mixed number to an improper fraction to see if we had enough for a dinner party, enough cornbread for a dinner party, which we found out we did. So let's go ahead and move on. I'm going to actually turn the page to page 303. So yes, I am skipping a page. I just believe we can move on. We're going to do 4 problems that have something different about each one, and we'll go over those, and then we'll have 4 or 5 questions at the end of this Edpuzzle so that you can try some on your own. So let's go ahead and get started. The first question I am going to work with is 1 1/8. And I need to make this into an improper fraction. Okay? Now the way I'm going to do that is I'm going to take this number 1 and I'm going to remember, let's turn this a little bit. Does this straighten it out? There we go. I'm going to remember that 1 can equal any fraction I want it to as long as the numerator and denominator are the same. So I can make it 1 over 1, 2 over 2, 7 over 7, 25 over 25, or 500 over 500. It doesn't matter. All of these are equal to 1 because the numerator and denominator are the same. So instead of working with 1 and trying to figure out what it is, I'm going to take this denominator, which is 8, and I'm going to make 1 into 8/8. Okay? Here, let's put a 1 right above this just so we remember. Oops, you can't see that up there though. So we're back up top here. 1 is 8/8. Now we're going to, so we've taken our 1. Now we're going to take our 1/8 and we're going to add it to our 8/8. And we're going to do 8 plus 1 is 9. And we don't add the denominators, so we still have 8 on the bottom. Our new fraction is 9/8. 1/8 is equal to 9/8. And just like that, you converted a mixed number to an improper fraction. Let's go ahead and try to do it the other way, though. Let's try to bring an improper fraction to a mixed number. So let's go ahead and erase this right here. And let's do 6/5. 6/5. Let's just leave it at 6/5. And let's bring this down a little bit. We'll put that at the top. Okay. So we have 6/5. Now, first things first, I'm going to go back to that magic number 1 again. Remember, it can equal whatever it wants. 1, in this case, is going to equal 5/5. As long as the numerator and the denominator is the same, that's all that matters. And since I'm working with a 5th, I'm going to use 5ths here. It just makes the most sense. Now, I'm going to subtract 5/5 because I know I'm subtracting 1, and then I'll see what's left over for the rest of my fraction. So, 6/5 minus 5/5 equals 1/5. I'm not going to subtract anything else because if I subtract 5/5 again, I'm going to end up in the negatives. So what I'm going to do now is I'm going to take my 1 and I'm going to put it with my 1/5. And by putting them together like this, I also have 6/5. So my mixed number is 1 1/5. And this is equal to 6/5. And we can even check our answer if we really want to. Here, let's go ahead and do that. Take these two right here, right? And we're going to split it up. Am I doing this right? 1, 2, 3, 4, 5. Yep, look at that. Not the best one on that second one, but let's take a look anyways. So I have 1, 2, 3, 4, 5. So that's one whole. That's 1. And this is 1/5. Now, depending on how you count it, you can either have 1 and 1/5 or 1, 2, 3, 4, 5, 6/5. Sorry that black doesn't show the best, but I just wrote the numbers 1, 2, 3, 4, 5, 6 in those shaded areas. But there you have it. We checked it, we double checked it, and we know that 6/5 is equal to 1 and 1/5, and that is our mixed number. So let's go ahead and do 2 more, because we got a couple more little challenges here. But once we do these last 2, I think you'll have the hang of it. So let's take the number 2 and 7/10. So we have a mixed number, 2 and 7/10. Now, again, I know we're working with 2, but we're going to take it back to 1. 1 is going to equal 10/10 this time, because our denominator is 10, and as long as our numerator and denominator are the same, we can do 10/10 equals 1. So we're going to split 10/10, 10/10, and 10/10. 2 is now represented right here. So 10/10 plus 10/10 is the same as saying 2. Now, we're also going to add 7/10 because we still got it hanging out over here. So 7/10 is obviously our 7/10 of, let's just do this right here. If you look, we still have our 2 and 7/10. But let's go ahead and add this up together now at the top. So we have 10 plus 10 is 20, plus 7 is 27. 10, 10, 10. All our denominators are the same, so we're going to leave it as 10. So our improper fraction is now 27/10. And let's say this number was 3, then we would have added 10/10 one additional time. So we would have had 37/10 instead. But just remember, you can always do this, and you can always add as many of these as you need to represent this number. Okay, moving on. Last one before you get to work on some by yourself. Let's try 12 halves. That is a pretty big number that's on that numerator compared to our denominator. However, let's not forget that, let's put this right here, 1 can equal 2/2. So what am I going to do? I am going to subtract minus 2/2. That will get me 10/2. 12 minus 2 is 10. Denominator stays the same. Let's put a 1 right here. Okay? Because this represents 1. Let's do it again. Let's put another 1 here. Just remember that it's worth 1. And we get 8/2. We're going to keep going until we can't go anymore. 8/2 minus 2/2. Another 1. Just a reminder, right? That equals 6/2. Subtract again. Minus 2/2 equals 4/2. Let's put another 1 there, remembering that our 2/2 really is 1. Minus 2/2. I told you I'm going to keep doing this until I can't go anymore. 4/2 minus 2/2 equals 2/2. Guess what? I can do it one more time. And that's what I'm going to do. 2/2 minus 2/2. Remember, this one is our 1. Equals 0/2 or 0. Now, you're probably like, I have no idea how that is even helpful. There's so much written on the board. But let's go ahead and see how many times we subtracted using the number 2/2. So we have 1, 2, 3, 4, 5, 6. The reason why we're not using this one right here is because it's not a time that we subtracted by it. It was a number that was just being subtracted. So keep that in mind. Be careful when you get into there. So we have 6. So our mixed number is actually just a whole number. Our answer is 6. Now, I'm going to erase all this math. I'm going to draw a picture to show you that I'm telling the truth and I'm not just being crazy right now, okay? So we're going to double check our answer. In fact, I'm going to erase everything. Oop, hang on one second. There we go. We're good. My screen went blank there for a second. So right now, after all that math that I just had, we said 12 over 2 is equal to 6. Let's prove it. 1, 2, 3. I drew those kind of big. Here, anyways, we'll bring it down just a little bit farther. 4, 5, 6. Cut them all in half. And guess what? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 half-size pieces. 12 halves does equal 6, because if I were to shade all of this in, I would have 6 whole circles. So just like that, 12 halves does in fact equal 6. You can always draw a picture to double check your answers. And that is it for today. If you have any questions, please feel free to ask. Make sure you stick around to the end of the video. I will have some questions on the Edpuzzle for you to try on your own. Answer those, and then you will be good to go. So with that being said, see you later.